My dear students, welcome to chemistry class. Now we will see the different types of crystalline solids. What is ionic solid? It is made up of ions. So its constituting particle is ions. It is made up of ions. The force of attraction is electrostatic or Coulombic force. It involves electrostatic force between ions. It is hard but brittle. It is hard and brittle. Fourth one is it is insulated in solid state. It is insulated in solid state but conductor in molten state or in aqueous solution, but it is conductor in molten or aqueous phase, aqueous state. Examples are NaCl, MgO, ZnS, even CF2, ammonium phosphate, lithium bromide, potassium sulfate, calcium chloride, etc. Now we will see covalent or network solid. It is made up of atoms and its binding force is covalent in nature. It is hard, it is insulated, and it has very high melting point. Its examples are SiO2, silicon carbide, aluminum nitride, diamond, graphite, etc. All are the covalent solid. Covalent solid. Covalent solid is made up of atoms. It is made up of atoms. It involves a strong covalent binding, or it involves simply covalent bonding. It is hard. It is hard. But here is an exception, graphite is soft. It is insulator. It is non-conductor of electricity. The fifth one is it has very high melting point. Very high melting point. Its examples are diamond, graphite, silicon carbide, aluminum nitride, quartz, that is SiO2, are the covalent solid. Even silicon is a covalent solid. Now we will study molecular solid. Molecular solid. It is made up of molecules. Made up of molecules. It involves forces like London dispersion force, dipole-dipole interaction and hydrogen bonding. It involves force like dipole-dipole interaction, London force, dipole-dipole interaction and hydrogen bond. All are insulator. It is insulator, that is, does not conduct electricity. It has very low to low melting point. Low melting point. Its examples are argon, even CCl4, H2, CO2, H2O in the form of ice, even HCl, SO2, etc. It involves London force, though it involves hydrogen bond, and these molecules involve dipole-dipole interaction. The fourth solid is metallic in nature. Metallic solid. Now we will study more about the metallic solid. It is made up of positive ions in a sea of delocalized electrons. Metallic solid. All metals are metallic solid. Even alloys are the metallic solids. All metals that you know, iron, copper, magnesium, even brass, bronze. Brass is copper, zinc. Bronze is copper, Sn. It is made up of positive ions in a sea of delocalized electrons. Made up of ions, that is positively charged ions. Positive ions in a sea of delocalized electrons. Delocalized electrons. It involves metallic bonding. Metallic bonding. It is hard but malleable and ductile. It is hard but malleable and ductile. It is conductor in solid state as well as in molten state. It is conductor in all state, in solid state. It has fairly high melting point. Metallic solid show thermal conductivity, electrical conductivity. Thermal conductivity is due to mobile electrons. When a metal is heated, the kinetic energy of the electrons in that region increases. The energized electrons move towards the cooler part of the metal and give excess of kinetic energy to the electrons present in the cooler part. Now the electrons in the cooler part energized. These energies or these energized electrons now move and give their excess kinetic energy to other electrons. The process continues and heat is conducted throughout the metal. So metals conduct heat. Thermal conductivity is the property of metallic solid. Similarly, electrical conductivity, it is also due to mobile electrons. In a metal crystal, electrons move equally in all directions. But when a potential difference is applied across a metal, the electrons move towards the positive electrodes. The moving electrons carry the electric current from one point to another. Thus, electrical conductivity is due to the directed flow of electrons towards the positive electrodes. As temperature rises, its conductivity decreases due to increase in resistance. This is the effect of temperature on electrical conductivity. It decreases with the increase in temperature. It is because when temperature is increased, the positively charged kernels also start vibrating and interfere with the movement of electrons, and therefore its conductivity decreases with rise in temperature. Metallic bond has no directional character. Therefore, wires of metals